The planets work in almost the exact same way that the sun does. They're very, very similar. There's only one slight difference in the LHA section of the calculations and one even slighter difference in the altitude corrections. So when you look at the planet section, you can see it's arranged pretty similar to how the sun is, where they've just got the GHA, the hourly GHA, and the planet's declination mapped throughout the course of the 3 days. You'll also notice these numbers at the top, seeing negative 3.4, positive 1.4, minus 1.9, and then those change throughout the year as well. You can see they changed a little bit here. That's the magnitude of the planets, so how bright they are. They change throughout the year. Remember, magnitude is measured with lower numbers being brighter. So Venus is the brightest of the planets because it's the one closest to us. And you can see Jupiter, or actually Mars is the dimmest because it's so faint. Jupiter and Saturn, despite being further away, they're so large that they do produce more light. Other than that, what you need to know firstly is that while the GHA, of course, still increases to the west, there is an additional correction factor called V on all of them. And you work V in the exact same way that you work declination. Why this is, I don't understand fully the theory behind it, but the planets, their course through the sky is less consistent than the stars or the sun. I mean, that's how they were first identified as being different, is because they move along their own paths. And so as a result, there's kind of more going on to how westward they are at any given time. So in other words, when you find its GHA, you take its hourly GHA and you apply the minutes and seconds corrections in the increments correction portion. But then you also interpolate the V value like you would little d, and apply that as well. In this case, Venus is subtracted, whereas Mars would be added and Jupiter and Saturn would both also be added. It doesn't impact, like it should not influence how you work on the minutes and seconds, but it is adjusted to it as well. You do both at once. Declination works the exact same way, where you just interpolate with the little d value. The only difference here is the planet's declinations do deviate within these 3 days, meaning sometimes they rise, sometimes they fall. This is also very true for the moon. I hope I'll be able to find an example in here. Maybe you can, but you can see Venus is increasing throughout this whole period, it looks like. Of Mars. Mars is increasing more slowly. Well, these all happen to be... Saturn changes very slowly. I can't find an example. However, I know it can vary more than it does with the sun. It can occasionally go in the opposite direction. And as a result, I know for a fact this happens with the moon a lot, but it could happen with the planets as well. So instead of just going down to the bottom of the page and saying, oh, this is positive or negative, or just seeing the general path, whenever you get this, you should look at the exact time. So if we were looking at Jupiter at, say, from 05 to 06 on this day, you'd want to come to that second and see, okay, it increased from 05 to 06. So this 0.2 d value here is plus 0.2. If ever it was negative, you would want to do negative. The point is just don't look at the whole stretch of time. Look at specifically that point in time and compare it there, because it's not as consistent and predictable as it is with the sun. So those are the two differences here. You just come to the GHA, you include this to your corrections alongside the minutes and seconds, and you're more precise with the little d value for declination. Now, the only other thing is when we come to stars and planets for the altitude corrections, you can see, obviously you don't use the sun box, but the stars and planets, it's really the planets that get more interesting here. Saturn and Jupiter, you just treat like stars. You just use their star section. However, Venus, you use this section of this column, and you can see it's broken down by the time of the year. So the majority of the year, from January to late September, you use this column. From late September to mid-November, you use this one, and then from mid-November to December, you use this. I don't know what's going on with Venus throughout these different times, but clearly the scale changes. And you can see it only changes by a very small amount. So the main body corrections for Venus are really pretty minor, but they do vary throughout the year, so you want to account for that. Mars, I don't even understand why they bother including this, but you can see for the entirety of the year, at any level scale from 0 degrees to 60 degrees in the sky, you just add 1/10 of a minute, and then you're done. That's your whole main body correction. Which does bring me to a good point that I forgot to touch on before. Just like how we said you shouldn't really take shots of the sun of any body below 10 degrees in the sky. If it's that low down, you have to deal with refraction and it messes your shot up. You also should not take shots above 60 degrees in the sky. It's not because refraction is going to become an issue. It's just because when something's that high in the sky, it's hard to explain unless you physically do it, but it gets really difficult to measure it off of the sextant. When you're measuring a sextant, you swing it back and forth like this. And as you do that, you can see in the sight the body kind of arc up and down at the horizon. And that's how you find when the body is right at the bottom of the arc, which is when you want to take the shot when you're actually lined up with its azimuth. That arc becomes shallower the higher the object is. So anything above 60 degrees, you'll be swinging the sextant. You'll be swinging the sextant like this, and you'll just see the body move back and forth, barely changing in height. It makes it really hard to get a good, accurate measurement of the body. So just like you shouldn't go below 10, you really shouldn't go above 60. And that's why for Mars, you can see they only list the altitude corrections between 0 and 60. Realistically, above 60, it's probably also just plus 0.1, but you wouldn't take that shot. So those are the only differences for the planets. I think really quickly we'll do an example. We probably won't even do as much work as we did for the stars, but we'll just kind of really fast run through how you would do specifically the H and D. So let's say, I don't know, we're going to take Saturn. We're going to take it on the 1st of October. And we'll pick an, I don't know, 22 hours, 5 minutes, 20 seconds. We'll just say that this is the exact GMT time. There's no point in going through all the work of all the other preparations because you know how to do that already. Or if you don't know how to do that already, just go back and watch the other videos. All right, 1st of October, we're gonna come to Saturn, and we're gonna look down, I'll just write GMT here. We're gonna look down for 2200. So you can see for 2200, Saturn has a GHA of 148 degrees, 21.4 minutes. And then a declination of south 02 degrees, 49.6 minutes. And then under that, we're going to do minutes and seconds for the GHA, and we're going to do little v. Then under the declination, we're going to do little d. So for little v, you can see down here that for Saturn, it's 2.2, and for declination, it's 0.1 for little d. 0.1 and 2.2. We know this is added because that is provided whether it's added or subtracted for the little v section. For D, we don't know, so we're going to come back to the difference between 22 and 23, and you can see it increases. It's actually written as 0.2 here instead of 0.1, but that's because it probably was a rounding error, and we can still operate off of 0.1, so whatever. We get 0.1 here positive, so we now have all we need for that. We come to increments in seconds, or increments in corrections, sorry. And you know what? I'm going to change the time to 22:45 so it's large enough that we can kind of tell what's going on here. So we'll skip all the way to 45 instead of 05. For minutes and seconds, we're going to go see suns, planets, Aries, moon, sun, and planets. We're going to come down to 20 seconds. Gives us 11 degrees, 20 minutes. 11 degrees, 20 minutes. And then we're going to look at our V and our D. So V is positive 2.2, which is equal to, you see right here, V and D both scale the same amount in the same way. And 2.2 is equal to 1.7. So we're going to set that equal to positive 1.7. And then D is 0.1, which at this minute value is equal to 0.1. Or 0.1, sorry. Now we're actually going to add these all together. So we're going to get the GHA of, by the way, just to practice the planets here, we're working with Saturn. So instead of just writing GHA, we're going to write GHA of Saturn using the Saturn symbol. Remember, that's Saturn, and if you wanted, that would be Jupiter. But here we're using Saturn. We add these together, and by the way, the little v is a minute value. So we're going to do 148 plus 11, and then 21.4 plus 20 plus 1.7. 21.4 plus 20 plus 1.7. Wait, I did that wrong. 21.4 plus 20 plus 1.7. 43.1. And then 148 plus 11 is 159 degrees. So there's our GHA at the exact time that we measured. Declination is just plus 1. So we're going to do dec south 02 degrees, 49.7 minutes. And then with all that said and done, if we were to later go on, everything else would be the same. Finding your assumed longitude would be the same. Finding your LHA would be the same as anything else. So you're still going to do plus east minus west. That's all going to carry through. HS to HO. Dip is going to work the same. Stars and planets. We're using Saturn, so we're not going to deal with this. We're going to use the stars and planets section. I didn't give us an HS, but we'll just say, let's say it was something around 14. We'd go here, minus 3.7. If we were working with Venus, we would come here and see that we're in the 1st of October. So that's between September 28th and November 1st. So we would use this value, and it would get us plus 0.2. If it was some other time of the year, we'd use another. If it was Mars, we'd use here. Just always check. It will be labeled for you which planet you're using, what time of year, whatever it might be. Use the appropriate column. And that altitude correction plus what we went over here are the only things that are going to separate planets from the sun. So if you know how to do the sun, it's not that difficult to learn planets.